Yeah. Alright, so I'll be doing a live repair today. Today I'll be repairing mostly MacBooks. See how much I have here, including this one. So I have this one, and I have a board here that I'm working on now. So if I can repair 3 of them for this stream, Apple, all 16 inches. This one is a A2141, this one is a A1990, and this one, oh, they put the thing over it, so I can't see. Alright. So alright, so I have this MacBook A2141 here that's not turning on. And it's reported that it's not turning on, no power. Oh God. Alright, so who's that? Top tier Chippy? Who is this? Who's top tier Chippy? Dev star, Dev. Devon? Oops. Duvi. Oh, Heron. Heron, what you fixing now, Heron? What you fixing? HP stream. What's wrong with it? Yeah, Paul. Yeah, Paul was planning to come and check you. We'll have a laptop for Stuart for me. For Stuart. Alright, so I see I'm gonna have a guest. Seems I'm gonna have a guest today. For today's stream. So each stream, normally on the weekends I have a guest. You bringing a job? Okay, Heron, so it's no power. Alright, so I will begin. Alright, so I have the board here. I'm going to plug in the power. Alright, so as you can see, we have 5 volts here, but no boost. This is the A1990. So I have 5, let me flip it around. So I have 5 volts here. Right, it's taking 248 milliamp. On the DC power supply, they are between 10, 100 milliamp. It's not turning on. Yeah. Not turning on. Alright, let's try the next port. I get the same thing. I get 5 volts, not turning on. Let's try the other two on this side. And I get 5 volts. It's not turning on, the current is the same. Let me see this side. I get 5 volts. And 242. Try this side again. It's not taking anything there. 245. $239. Alright, so I'm gonna check PP bus section. So Heron, can you fix it? Is it troublesome? Alright, so I'm gonna check PP bus. So let's take a look at the meter. Alright, so PP bus is shorted or not? And I have, that's right? Oh, sorry. And I have no discharging. I have 440. Alright, so it's no charging. And it's 2, 3, 7. Alright, that's fine. So it's now 389, 390. So PP bus is okay. Cleaning up the board. Oh, so it fix that. Oh, still checking. It's a liquid damage unit. There's a liquid damage unit there. Okay. Alright, so PP bus is good. Let me check. So this is a T2 base board, as you can see. It's a T2, right, which is a Intel hub here, and it's an Intel CPU, right? So so let me check the power supply for the NANDs. We get 300 for PP. 2.5 volts is okay, right? 0.9 is okay or not? Yes. 1.8 volts. Yes. So all three main supplies are okay for the NAND, right? Let's check for the RAM. Right, we get 146. That's excellent. Right, this is for the graphics card. This is for the video memory. We have main RAM here, so let's check for the VRAMs. VRAMs is okay, good. The core supply for this is the graphics card. Let me see if these are connected in parallel. No. These are connected in parallel. Yes, so these are the graphics card power supply coil. Right, this is for the VRAM. Right, this is for the RAM, yes. Yes, this is the VRAM. And this is the core supply for the graphics card. Right, it's 3 Sorry, this is VCC SA. Excellent. CPU core is okay or not? Excellent. The graphics card is okay. VCC GT. Excellent. VCC GT is fine. Right, 3 volt and 5 volts. Should be here. Yes. 5 volts is okay. 3.3 volts. Excellent. 3.3 volts is also okay. They're all good. So could it be that one of these power delivery chips are not working? We have a port. We have 2 for this port here. This is one, and another one here, and we have 2 on this side, which is controlling 2 of these hubs right here, which is controlling these 2 Type-C USB ports here. I have to go under the microscope. I'm going to check the resistance for PP3V3 LDO output on all of them. Okay, so So I'm gonna check. Let's go. Let's do this. Alright, so this is one here. Alright, CD3215 C00. Alright, so I'm going to check around the area here for any shorting. They always break. Alright, this is PPDC in. This is PPDC in. Main supply, which is taking the 5 volts. After boosting, it should get 20 volts here. Right, that's good. Right, PP3V3 LDO. That's good. PP3V in. That's also good. Right, CC configuration channel 1, CC2. Yes, they are both good. Alright, so we don't have any fault there. Let's check the next one. La 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 la. Alright, so here we go. So this one is PPDC in. PPDC in. On this side is good. PP3V3. PP3V3 in LDO. They are both good. No short there. Right. No short there. Alright, CC1, CC2, all good. CC1 and CC2 is good. CC1, CC2 is good. No problem there. This one. Alright, so I don't have any shorts, so let's check the next two. Alright, this one, let's check this one. PP3V3 in, PP3V3 LDO, that's good. Alright, CC1, configuration channel 1, configuration channel 2, all good. Next one, PPDC in. What's that caught under the camera? PPDC in. PPDC in is good. Alright, so this is PPDC in as well. And PP LDO. And they're all good. So I'm not getting any short. So why is it not boosting? Alright, let's check the EEPROM chip for the chips. Right, let's check pin number 1 resistance. Also good. The main supply. That's also good. So there's no short. I'm going to check the BIOS to see if the chips are reading correctly. If they are reading the EEPROM chip correctly. Okay. All right. Let me get the oscilloscope. All right, Manchester United is now starting to play and I can't watch. And I want to watch that match, but I'll catch it in the later on. Is that selected or not? Sometimes I wonder if these hubs are working. Alright, so I will now get the oscilloscope ready. Alright, so oscilloscope is ready. Turning on. I'll set this to 1 volts per division, and my time base is roughly 500 microseconds there, and my trigger level is set to, my trigger type is set to falling edge. It's on the rising edge. All right. All right. So this is our EEPROM chip. Let's check pin number 1. I give power. Yes, we have read. As you can see, there's read. So the main power delivery chip is reading. Let me check the next one. I give power. Yes, we have read. All right, so I'm trying to find. All right, let me check again. I will give power. Yeah, ready. All right, so we have read. Hey, it's boosting. What the? The laptop is not working. It wasn't boosting before. See, I have 19 volts now. It's boosting. And take a look at the DC power supply. As you can see, it's turning on. I wasn't getting that a while ago. That one was a bit tricky. I wonder what's happening. It wasn't turning on. It wasn't turning on. That's interesting. Wasn't turning on. Let me try again one more time. It wasn't boosting. Let's try all ports now. Five volts. And it's actually boosting, but it wasn't boosting before. That is very, very interesting. So the laptop is fully functional. At one point I'm getting 1 amp, exactly 1 amp, 900 milliamp there about. That's interesting. Let's try the next side. Hey, it's boosting. That's interesting. 1.3 amp. That's interesting. The laptop is working. I'm trying the other one. And it's boosting and the laptop is working. I can't believe this. So I'll put it in the, I'm gonna screw up this machine and see if it works. Very interesting. All right, so let me clean this. I'm just cleaning the chassis here. Why? I'm not sure why it turned on. I'm not sure because I was checking all resistance and I don't know why. I don't know what happened. It's weird because it wasn't turning on. It wasn't turning on. As you can see, I plugged each. I plugged the power supply in each of the 4 ports and they didn't turn on. It didn't boost to 20 volts. And all of a sudden now it's starting to boost in. I wonder if it was something with that BIOS. Because as I touched that BIOS pin number 1, chip select, to see if the chips are reading the BIOS, the EEPROM chip, it started to work. Maybe. I don't know. It's weird. I don't know how to explain this. Because all I did was just touch the probe with the pin 1 of the EEPROM chip to see if the chips are reading. Right? So as you can see, let me show you again. This chip, this one I checked rather. This is the EEPROM chip that I checked right here. This EEPROM chip here, I checked here with the oscilloscope. So I'm going to increase my time base to about Uh, about 10, let's put it to 20 milliseconds, if I can get it. 50 milliseconds. Yes. Yeah, yeah. 11:45. Yeah, yeah. Yeah. Okay, so as you can see, I was checking here. Alright, this is pin number 1 of the EEPROM chip here. And I will give power. What's that? I'm getting an interference here. I don't think I'm grounded properly. I'm not getting that good ground connection there. Let me find a different ground source. Alright, let's check again. So as you can see, we have reading there. And the EEPROM chip is reading, pin number 1. It's reading the contents of the ROM. We have a guest here. We have a guest. He's taking a laptop. Paul! And I'm a live stream.
Yeah. Thinking cap that, bro.
I'm a pagan cap. It's Christmas.
Pagan.
It's Christmas, yeah? See there? So you carry now. Why these MacBooks keep dying? Dead or what?
No, not dead.
Oh.
Charging.
This is the same one you carry?
Yeah.
It's a 16 inch. Yeah. Alright, so this one. You can't adjust it. Long time for me.
Yeah.
You can't adjust it, man. The lever there underneath the chair can carry right down to the knee height.
Okay.
Yeah. Feel good? Oh, because Stuart did link me saying if you carry the drop of the same Samsung, the board it burn up somewhere. It burn to a point where you can't fix it, but it'll take whole heap out of me. If you bridge out, I have to build back the trace. You see me some rough. Rough. Alright, so.
Another one enough, but it's a different CPU from that.
Who the same use?
Yeah.
You have another one?
Yeah, I totally didn't care about the lady I said to fix that one first because in high school.
Yeah, because the chip of the power the main power chip burn, so me burn, man. What happens is that we'll get it solder, you know. We get light, you know, but we know it not solder correctly. Because I have to go run, but it's risky. The wire go touch 19 volts and 19 volts can send that the 19 volts can touch something enough to touch and burn the CPU. So we cancel it. Yeah, so on the live stream. I live. Yeah, you know the stream.
Oh. Hi guys.
Yeah, man, see there? They're on YouTube. See there live 37 minutes now. Yeah, Saturdays, live days. So I have 5 people have viewed now. For now. Yeah, man, live. 18 views we get in our but ooh, dep on it now I watch now. So I'm gonna lock up this. Stewie. Yeah, so I'm tell him say if I left it back with you. Right, to the chat there. Why did it turn on? Why the laptop just suddenly turn on, Paul? I don't know what going on. I didn't never turn on. Alright, so I'm gonna check again one more time. Yeah. So as you can see, I get reading there. Yeah. Let me check again. See, as you can see, we have reading there. Right, the chip is reading. So it's reading the contents of the RAM there, and it's turning on.
So I want to do that.
Which device that? The oscilloscope is a PC version to this.
Oh.
So it allows me to connect it to this, so they can see it on the screen.
Okay.
So instead of use the camera point on it.
Oh, gotcha.
So it's a PC version. Same connection then. Yeah, you know I have this? I never remember. From 2016 I have it. So it's the same thing, just a PC version. Alright, so I'm going to put this back together.
You have to add your email address.
My what? Who said that? Yes, sir. Apple ID. Oh. Alright, so I'm going to screw this back together. And see what happens. It's still turning on. It's still turning on. No, plug out. In station plug out. Yeah, right now I use. I not really left them plug in. You go from morning? You go shop from morning? You go shop from morning?
Yeah, I'm diagnosed on Dex for all it, but the board, part of the board burn and next part is
That's it.
some black shit on it. But I'm all something I think I want to spend time on that. All something probably some megabyte
Oh.
RAM
Yeah.
from DDR1.
Yeah, it's man, you score them score fast. Man, them score so quick. Okay, so
I'm sure I said over that side there.
yeah, you should see the wall stays. You want it dressed, brother. You know nobody can dress them thing there.
Yeah, fix the leak first.
They say there's a paint where hold the leak.
Yeah. Spray valve wall.
Cause I don't intend to paint that every time, you know, brother. I just want to get one paint and know some the dust then. Yeah, cause I hold for dust that, you know. Alright.
I'm still going to go and put it up.
Yeah. Trying to think them over there, so. Screwdriver. Can you remember? Safin. Oh, this out of the way. Okay. Same. I think this is one. Some more. I mean, if let's try them. So when school lock, so next week or the week after next? Probably a week after next. I think of next week. I never said the exam, they don't finish the exam yet.
So what about next week? Primary one.
I know. Prep school might lock next week. Just like the going from last night, from this morning. Eh? Eh? I don't have no power from after 4 this morning. From 4 o'clock this morning, I don't have no power, you know. Oh, from 4 o'clock this morning. And it go Monday night, Sunday night. So I wonder why the power cuts so often. They not fix the thing them properly or something, rather they might use some cheap things they might use and maintain the power. I want some cheap something them I use right now.
I can put it wide, go on.
Yeah, some cheap thing them I use. They not spend money. Cause if light go away, if the power go away Sunday night, I'm getting back Monday morning and then it go away this morning again. They not do something right. It's like they not fix it good. I use some cheap things. So you know, there's a pagan holiday. God. Hope a life, hope a animal lose them life, you know. Hope a hog lose them life, you know.
So they are going to turkey them.
Eh. Whole heap of goat lose them life, but mostly hog do, cause the ham. Twin do right.
Try port first.
Oh, the port, alright.
This is what they call.
Hmm?
I plug into this.
Hold on, I forget, I put the power over there. Why WhatsApp takes so long for hang up? I always wonder why. You ever notice? It take it ring long. Oh my God. So the power. Plug out the lighter for now. I'm gonna use it. Oh, and the switch on there, so. So this. You know it already. You have one. All right. Before I go any further, let me see if we're getting some powering up on some display on the screen and everything before I fully close up the unit. You know, so upon the screen, we think it's a 15-inch, a 13-inch laptop. Never know it's actually a 15-inch Mac. Yeah, upon the, in the video it looks smaller. Yeah.
On the port.
Cover on the port. Alright, so I'm going to connect the power now. And I get 5 volts and it's boosting. Yes, I'm getting. Eh, come on. See, it turns on, so I don't know what happened.
turn.
Which one?
One console.
Just press it once. Yeah. The lock the button. It's,
Oh, yeah.
and then if you want it brighter, you press again. If you want to change the tone, you double tap. Double press.
Disco?
What that?
What?
No. Come with another light. But I me buy that one there. Different. Yeah.
Wow.
Hmm?
Hallelujah. You're talking?
Huh?
You're talking?
If you talk to who?
Okay.
Oh yes, not quite. All right. Do another test. All right, so it's boosting now. As you can see there, it's now boosted. It's now on. As I said before, I didn't know what really happened. It just turned on. All right, so I will finish this one. Alright, so just making a final test here before putting it away. Worked. Okay, so turn on this light. Alright, so we have another guest here. Camera 1 is out. Oh. Okay, so we have another guest here taking apart a MacBook for me to look at shortly. Oh, my feed is gone. I think I have a short. Alright, so one is being taken apart there. Alright, so I'm just waiting for that one to be disassembled. Yeah, the board, I'm always dirty. I forgot outside I got clean. Oh. Alright, so the board is kind of a bit dirty. I want to call this.
The last one came up.
It's chip in, chip out. Say liquid here. Let's say liquid on the port.
Yeah, look for it.
Here. Alright, so this one is a A1398 and it's not charging. Not charging. It turns on, but it's not charging.
You're not getting orange or green light.
No lights. There's no lights at the MagSafe coming on the MagSafe on the charger. Alright, let me just remove the dust. It's a blanco. I wonder what going on. Yeah, removing the dust before I work on the board. It's just a bit dusty. I don't think I ever show though, but I have to switch the camera. I don't know why, some short in it. No, I never show. I never switch over the camera. I have to switch it over. Something going on here, someone. Have shots already?
You?
Oh. You know?
If it be for live stream, then
Just a blank out. Alright, so let's see what's going on for this board. So it's now cleaned. So I will get the charger for this one. Long time, smell with you. Alright, so I'm just cleaning this extra dust. Alright, so let's look for any inspection. Let's for inspection of the board for any burn, any corrosion, any form of liquid intake or any form of mildew. Alright, so checking on this side here, and it seems pretty good. Zoom in some more. Alright, this side is also good. It's the DC jack area here. He said that he sees some liquid corrosion here. Looking all right. Looking good. All right, let's take a look down this side here. All right, there's also good. This is a 820 3787. Okay. All right, this is the charging chip here. This is our standby chip here. All right, for 3 volts and 5 volts there. It's good. This is the video memory. Alright, and this is the CPU power supply chip there, that's also good. This is the camera control IC here. This is the SMC or the EC. This is the camera control IC here. All good. Alright, everything seems good on this side under the PCH here. This is under the PCH section here. All good. Next side, this is the backlight area here. Backlight section is good. Let's take a look on the USB supply section and the audio. All good, all good. Display connection, good, 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 good. Alright, so don't see anything obvious. Alright, so there's nothing obvious there. Alright, so I'm plugging in the MagSafe now. Oh, we're getting lights. I don't know if you can. Oh, it's gone. The light was there, but it's gone. Not getting any lights. I'll try another port, yes. I want to try another port. We're not getting any lights. No lights. I'm removing, unplugging. I got light and then it just. There's no light. Alright, let me try another port. Oh, here are the ports. What up? Oh, it's a truck. Yeah. All right, so we have ports here. These are some new ones.
Then I use the other light.
The what?
Pretty one here.
Light what up?
Pretty light now. That's it, brother.
Pretty light? No, no, no.
The big cone one.
Oh, it took up smear. It took up smear. It took up whole massive. But we should buy such a big one.
Oh.
Yeah, we should buy such a big one. Alright, this is a new port. Alright, this is a new port. As you can see, there is the seal on it. Overlove. The most wonderful time of the year. I want to see it once. So if it does make use of it. Alright, so I'm going to put a new port here. This is a brand new port. As you can see, the seal is on it there. Yeah. So I'm going to put a new one. See what I get. It should be working. I just feel it's a port. Let's go. And we still don't get any lights. As you can see, there's still no lights. No lights, no orange light, no green light. I'm removing the power and plugging it in, and there's no lights. So that means it's a motherboard issue. So the motherboard is at fault. Every time it's the board. Why? In Paul? Everything. The board. Why? Everything is the board. Alright, so the port is okay. That's a brand new port there, DC jack there, and it's not working. Still. Oh. Can anybody tell me why it's not turning on? Alright, so I am going to check. With the oscilloscope to see if the SMC, the EC is actually reading the contents of the charger. Alright, so I'm gonna head over to the schematic here. So we're gonna type in the board number. So it's 820, right, hyphen, right, so it's a 3787, I believe. Let me see. 3787. 3787. And here is the schematic, the board view, and we are going to take a look at this circuit here. So right here on the DC jack right here we have this system, or the sys1 wire. We're going to check the sys1 wire. So the adapter sensing is coming to pin number 6 here, and it's going to EXT, right, and this is INT internal, which is the system 1 wire. So we need to check this resistor here, R7029. This is a 2 kilo ohm resistor. And we're going to check if it is getting a power from VCC SMC BC underscore OK VCC. And this is going to the EC to read the system, the contents of the charger, to see the wattage of the charger, right, and how much voltage and certain parameters of the charger. So we're going to check here for R7029. And here is it. And it's on this side of the board. Right, so it's on this side, the back side. That must have a screen, man. Alright, so here we have, let me see. So this is this side here. It's at the edge of the board here. Yes, so let's go back to the microscope. Eh? Mm.
Oh. That's a quick last switch.
Yeah, this Alright, so first I'm going to turn on the oscilloscope. Is it on? Alright, so let's turn on the oscilloscope. Now we're going to check. Let me turn on the probe, channel 1. Yes, I'm capturing. Oh, I need to set my time base back to 500 milliseconds. Microseconds rather. And my time base is going to be 2 volts per division. And my edge type is set to falling edge. And my trigger level is going to be roughly 900 millivolts. Alright, 900 within that range. Here on. You want to be me, you know? You want to be like me. Alright, so first I'm going to plug in the power. And we are going to check. This is the adapter sensing circuit. Because what happened is that this laptop works with a charged battery. This laptop works with a charged battery, but it's not working from the adapter, so hence the battery cannot be charged. Alright. What is? Oh, that's just my move. Alright, so on the schematic, as you can see, right, so we need to check. Let me zoom in. So this is the chip that is going to sense in the charger. So pin number 1 is 3.3 volts, right? So pin number 1 and 4 is our main, and pin number 5, all pins. But pin number 4 and pin number 1 is my main concern, right? So pin number 5 is last. So pin number 4 and pin number 1. Alright, so let's check the voltages first. Pin number 1, pin number 4. This is pin number 1. I'm not getting a voltage there. Alright, pin number 4, no voltage there. No voltage, no voltage. So that means that this chip that is sensing the adapter is not getting any power. Right, so let's check the resistance of pin number 1 and pin number 4. So pin number 1, we get 538. Right, pin number 4, we have 632. Alright, so pin number 4, 632. Yeah, and pin number 1 is, we get 540. And that's also good. The master at work. Yes. Alright, so next I'm going to go to the charging section. Right, so the charging section is coming from here. This is SMC_BC, okay, which is going to indicate that the adapter is inserted and detected. Right, so let's search. This one. This is a pull-up line. R5187 is a pull-up by PP3.4 SMC or PP3.4 too. So it's PP3V3S5. So first let's check if you're getting 3.3 volt S5 on the main PP bus first. So let's go back to the overhead. So I'm going to check the resistance on PP3V3. So this is PP3V3 S5 and I get 117 5 volts S5. I get 399, that's good. PP bus, which is this fuse here, and I get 200, it's discharging and it's not charging. I get 400 and 617 there, that's okay. Alright, this is 1.05 core supply for the PCH. Yeah, that's good. This is a Haswell CPU, right? So this is the graphics card core supply. No, that's the video memory. This is the RAM supply. RAM supply is here, right? The graphics card supply is under here. All right, so this is the core supply. This is 1.7 volts, right? We have the core supply for the graphics card. This is 12. Right, this is for the VRAM, and I get 104, right, and that's all good. So we have no short. So I'm going to check if I'm getting PP bus. This PP bus is there or not? PP bus is there or not? 12 volts. No 12 volts. We're not getting 12 volts at PP bus. I'm getting millivolts, 150 millivolts there. Right? Is 3.3 volts there or not? No 3.3 volts. So can anybody tell me what's the problem? What's causing why we're not getting PP 12 volts, PP bus? Huh? 3? Yeah, about 3. No matter. Still I get constant views in it. 4 now. Interesting. Alright, nobody answer. Alright, so first I'm going to check the charging chip. So first I'm going to check the current sensing resistors that are sensing the voltage. Right, so SMCBC OK is coming from our charging chip. Alright, so let's go to U7000, I believe. So that's U7123. Oh, this is U7000. Okay. So the charging IC is here. This is a charging chip, U7100, sorry, it was my error. So U7100, we're going to search. And this is the charging chip. So as you can see here, we have the charging section, and these resistors I'm interested in. There's R7121. These are 10 ohm resistors. They normally break and they change value. And if they change value, then the adapter, the charging chip cannot be able to sense the current from the PP-DC in 3G in rush. Right? So if the voltage on this side is greater than the voltage on this is the negative side, this is the positive side, and this is the negative. So it's calculating the voltage by 20 times the amount of voltage that is generated here, and it is then calculated inside of the charging chip, and it is going to output the total amount of current which is coming out of this one, which is I. I stands for current, and the COMP stands for compensation, and we have voltage compensation, right? So these two signals are going to report to the EC to tell the EC how much voltage and current that the total system is producing in order to monitor the charging of the circuit. As you can see, this is called a compensation capacitor. If this capacitor is a fault, then the laptop won't charge. It will work, but it won't charge a battery. So if you remove this capacitor, this is called a compensation. See, charger current compensation, RC, which stands for resistance multiplied by capacitance. So the RC means RC, which is a capacitor, which is here, and we have a resistor here. So we have 1 kilo ohm resistor here, right? And then down here we have 0.1 microfarad capacitor. So that would be 1 multiplied by 0.1 microfarad, right? And the total of that time is a delay, which is in milliseconds. As you can see, we have a voltage divider here. We have R7110 and we have R7111 here. And that is going to a voltage divider. And that's going to tell the adapter input threshold. So the adapter voltage cannot be below 13.55 volts. If the adapter voltage is below 13.55 volts, that's not a correct adapter insertion detection signal, right? So this should be no more than 13.55 volts or above. Cannot be below 13.55. So that is, you have to bear this in mind. So I'm going to check these two resistors here, which is R7121 and R7122. And these are 10 ohm resistors. So let's go back under the microscope. Alright, so I'm going to go to the charging section here. And we're going to check if these resistors are intact. And this is the circuit there. So these are the resistors. These two. So let me go to the resistance gear. I should get 10 ohm. And I get 10 there. That's excellent. The next one should give me 10. Excellent. So I get 10.8. So the resistance are okay. Uncle Sam, why? Who's Uncle Sam Autos? Uncle Sam Auto? Oh, they are talking about the previous laptop. I don't know. Just turn on. Alright, so we're getting 10 ohms there on both resistor. So let's go for the next set of resistors, which is here. So these resistors are good. So we have the ones for the battery. As you can see, it's called charger chips. Current sensing are positive. Current sensing are negative. So one is 2.2 ohm and this is 0 ohm. So I'm going to check these. So that's R7151. And that's right there. So let's go back. And this is R7152. Right here. So they're beside each other here. So I'm going to check them. So let me go back to the microscope. Alright, so this one is 2.2 ohm. Alright, so 2.9, 2.8, 2.7, 2.6, 2.5, 2.4. Get in there. 2.3. And one more. You can make it. Come on, you can do it. Alright, that's in the range. Alright, this one is 0. 0, 0, 0, 0. Excellent. So those resistors are good. So I'm going to plug in back the power now. And I'm going to check the adapter, the main power supply, which is DC in. DC in is from which pin? So DC in is this pin here. So DC in, we have AC in, and we have DC in. Here is it. So DC in is pin number 2, and that's taking the voltage from this OR diode. This is an OR application of a diode, right? And it is taking from PPDC in 5 volts, S5 charger isolation, and it's coming through this current sensing resistor here. This resistor is acting as a shunt resistor. As you can see, it's a 20 ohm resistor, and this is to prevent any form of inrush current that is coming to the DC in pin. And there should be normally a capacitor here, right? Here, this capacitor is very important. If I remove this capacitor, that can cause too much current and can burn this chip, because during operation each component generates interference or electromagnetic interference, and that can cause voltage to fluctuate, too high, too low, too high, too low. So this resistor is used to limit the amount of inrush current, right? and then this resistor is acting as a protection resistor to limit the amount of current inrush, and the help of this capacitor to smooth out any clutter which is coming in from other components that are generating a lot of interference or electromagnetic interference, which can cause irregular voltage and unstable voltage. So it's basically a stabilizing type of circuit, and to ensure the stability of the voltage. So we're going to check pin number 2. You see that, Paul? Roughy? Good morning. Eh? Alright, so pin number 2, are you getting 20 volts or not? Yes, we are getting 18.7 volts. Right, so 18 volts is there, and this is the stability, this is the capacitor to stabilize the voltage. This is a decoupling capacitor. Alright, this is called a decoupling capacitor. Alright, so that it's okay. Why is Mac so complicated? You'd have to ask Steve Jobs. Alright, so you watch it on your phone? You live? It real time? Yeah. Alright, so pin number 2 is okay. Pin number 1 is okay. The next one is pin number. We're going to check adapter insertion and detection. Pin number 3. Right? Adapter insertion and detection is coming through a voltage divider here. As you can see, another path of PPDC in S5 underscore charge underscore isolation is coming to the anode side. This is the anode side of the diode, and this is the cathode. And another path is coming to pin number 3 to a voltage divider. So this is R7110 and this is R7111, yeah? And this is how much? This is 130 kilo ohm and this is 40 kilo ohm. Can anybody tell me how many voltages coming to this path here on the pin number 3? Anybody? Anybody can tell me how many voltages coming to pin number 3? No one? Alright, so pin number 3, let's do the mathematical calculation. So I'm going to take out my phone. Let me go back over to the overhead camera. And we are going to do this together. Yeah, we're on the overhead camera. That don't look good at all. Alright, so man, you lose. Football go on now. The 3-1, that don't look good, brother. Let me confirm it. You see something? It don't look right. Yes? Shit. Brother. No, I'm to Man U, boy. Anyway, so your side? Yeah. That's I don't know. Alright, so here's the phone, so I'm going to calculate. So the first resistor, you have to do this. It's very important because you have to know the mathematical calculation of the Ohm's law. So it's R1 plus R2, right, divided by R1 plus R2 multiplied by R1. And then you're going to divide that by the voltage that is coming in. Right? So that's how it works. So I'm going to do this in the calculator now. So this is the calculator. So R1, which is 130K, right? So R1, this is resistor 1, right? And this is resistor 2. So resistor 2 is 40K, 40.2 kilo ohm, and resistor 1 is 130 kilo ohm, right? So here is it. I don't know if you can see the screen. Yes, so the first one is 130, which is R1, right? And R2 plus 40.2, right? And that's 170.2, right? So 170.2, right, divided by how many? 19 volts? And that's 8.95. Right, so I'm going to multiply that by 40.2. That's incorrect. That's incorrect. Let's go again. So 130 plus 40.2 equal 170.2. Right? 19 divided by 170.2 0.2 is equal to 0.11, right? I'm going to multiply that by 40.2, and that's 4.48 voltage, as you can see. So I should get 4.48 voltage at pin number 3. So this is the correct calculation, right? So let's check if I'm getting call it 4.5 volts. You can just round it off to 4.5 volts. So I'm going to go on back to the microscope and I'm going to check pin number 3. So pin number 3, let's go. Alright, so pin number 3, I'm connecting the power.
So is 130 plus the 40.2, which is 174.
And then you divide that by 19. Alright, so pin number 3.
We divide by 19, we get 8.9.
No, you have to do it 19. You have to do it 19 divided by 170.2. You have to reverse it.
Oh,
Yeah. And then multiply that by the 40.2. Yeah, you get the voltage. So here is it now. So pin number 3 is supposed to be 4.5. Is it 4.8? Call it 4.5 volts. So let's go. 1, 2, 3. 1, 2, 3. So I get 4.4 volts. So that's fine. That's 4.4 volts. That's correct. So that can work. That's in the range. So we have adapter input there. Now we need to check pin number 13 now on this IC. So pin number 13 is adapter. So when DC in is coming in and AC in is coming in, then the chip is going to sense that the adapter is in the threshold. Then it will slowly release a LDO voltage, right, which is called ACOK. We also have VDDP and VDD. So VDD is an output which is going to come through this 4.7 ohm resistor to power the internal logic and the internal buck converter inside of this chip. So this is 5 volts. And then VDD, we have ACOK pin number 13. This signal is a key signal. And this is roughly 3 volts. So we're going to check pin number 14. And we need to check pin number 19 and 20. So pin number 19 is outputting 5 volts and it's going to power back itself to pin number 20 to turn on the internal buck converter circuit that's inside of the chip for internal operations. Alright, so pin number 13, 19, and 20. Pin number 13. So this is 7 and this is 714. Pin number 13 should be 3 volts. And I'm not getting 3.3 volts. Alright, let's check pin number 19 and 20. So it's 14, 15, 16, 17, 18, 19. Should get 5 volts here. Oops, my charger was plugged out. Let's go again. The charger was plugged out. Alright, so let's check pin number 13 again. And I get 3.3 volts. Let me see if we can get a better angle at the meter here. 3.3 volts at pin number 13 is there. It's gone. I was getting 3 volts. Let's see if I get in 5 volts at pin number 19. Yes, 5.5 volts. Pin number 20, 5.5 volts. Just checking. I was getting 3.3 volts at pin number 13, ACOK. Yes, 3.3 volts is there. Alright, it's going to the chip here. Yes, 3 volts. No? It's fluctuating. Let me see. So I get 3.3 volts at coming here. My new score back. Can't believe this. You can't see, you know. Alright, so pin number 13. Pin number 13 is coming through this here. The voltage is not stable. See? I'm getting 3.3 volts and it's going away. It's not there. It's gone. Nope. Alright, so 3.4. Oh, there it is now. Maybe I wasn't getting proper grounding. So I'm getting 3.3 volts at pin number 14. Pin number 13, sorry. And it's stable now. Right, we're getting 5 volts at pin number 19. And 5 volts at pin number 20. Right. So the laptop, now this section is fine. So all the working conditions here so far is okay. But we're still not getting a green light. So my next option now is to go to the part that I was before here. Alright, so pin number 1. 3.3 volts is there now. Right. Pin number 4. 0.9. That's supposed to be 3.3 volts. This is the pull-up, 3.4. But it's dropped to 0.9. Can anybody tell me why the voltage is dropping here? This is the pull-up line that the EC is going to read this line here. The EC is going to read this line to read the contents of the adapter, the wattage. So I'm not getting 3.3 volts here, I'm getting 0.9. I get pin number 1 is 3.4 volts, right? Pin number 5 is supply, 0.9. Let me confirm. Pin number 5 is adapter sensing. Yes, adapter sense, so that's okay. Pin number 1 is SMC-BC, okay, and pin number 4 is system 1 wire, and this is what we need to get the green light. Sys 1 wire. Alright, so let's check pin number 4 again, and I'm getting 0.8. That's abnormal. That should be 3.3 volts. So I'm going to use my tweezer and I'm going to remove the power. So let's go back to the overhead camera. Alright, so I'm going to use the tweezer here. I'm going to ground the resistor and I'm going to add power and see if I get lights. And I'm still not getting a light. Let me go again. Oh, I know what we'll do. I'll just use the switch. Alright, so still no lights. Alright, so let's check the resistance on that Sys 1 wire line. It's all good. SMC-BC okay is good. Sys 1 wire is good. And this is the Sys 1 wire resistor. How many kilo ohms? That's 2 kilo ohm there. So 3.3 volts is here, but we're not getting 3.4 volts here. Alright, so the Sys 1 wire is having a problem there. And this is going all the way to the EC. As you can see, this is the EC. All right, U5000. All right. Oh, we have lights now. That's weird. Hold on. Let me see. So I'm going to. It's gone. Alright, so I'm going to ground again. Not getting any lights. No lights. Alright, so first the EC needs to work. So the EC has three main working conditions. So you have supply, reset, and clock, right? So we're going to go to the EC, and that's U5000. Here it is. And this section over here, which is the working conditions, the basic working conditions of the EC. So we have U5000, we have SMC reset, we have VBAT here. VBAT is 3.4 volts, and it is PP3V3S5, right? So PP3V3S5 SMC, it is coming to turn on, and this should be always coming from PP3.42. So let's check PP3.42 section first. So PP3.42 section is coming from here. So this is PP3.4, this section here. Let me check the resistance, and I get 283. Alright, let's check if we're getting 3.4 volts there. Oh, we're getting lights now, but it's not turning orange. Hey, it's orange. What's going on? I wasn't getting that. And the computer is on. PP3.42. So let's try again. It's gone. So we're having an intermittent problem here. Can it be that something is wrong with the embedded controller? Yes, because I'm getting a light here, and it's gone now. There's no lights. Message was reacted. So let's check if we're getting PP3.3 volts. 3.4 volts is there or not? Yes, we're getting 3.4 volts. Yes, 3.4 volts is there for PP 3.4. So I'm going to check the working conditions of the embedded controller. This is the EC here. So alright, so the EC is right here, and this is the embedded controller. As you can see, this is the EC. I'm just inspecting the areas around here. Alright, so first I'm going to check if the working conditions first of the EC. So first we have supply, which is coming from PP3V3S5, and that's coming to here. So let's backtrack and see where this is coming from. That's coming from here, not there. That's not it. That's not it. Alright, so it's coming from PP3.42, and I am getting PP3.42. Alright, so we have supply already. So PP3.4 volts are coming to VBAT pin here, and we need to reset. Right, SMC reset is normally coming from another circuit here. Here it's coming from R5100, R5100. Alright, so we're going to check here. This is a 100K resistor. So I'm going to check here if I'm getting 3.3 volts. Right, since PP 3.4 volts coming to this side of the resistor, and pin number 2 should have 3.4 volts, which is going to reset the EC. Right, so I'm going to check there as well. So I'm going to check for R5100, and it's right there. Alright, so let's go back to the microscope. Alright, so it's up here. And this is the resistor here, this small resistor here. That's this one. So we're going to check if we're getting 3.3 volts there. Yes, 3.4 volts on one side. On the other side, 3.4 volts. So the EC is getting its reset signal. So reset signal is there. Next we have clock, but the clock only generates when it only generates for a few fraction of a millisecond, and then it stops. And this is a 12 megahertz clock crystal here. This crystal, right? As you can see, it's written 12. I don't know if you can see it. Right, that's a 12 megahertz clock, and it's going to oscillate only for a few milliseconds. Then when you press the switch, then it will oscillate again. Alright, so I'm going to check. So first, I'm going to apply some heat on the EC, because I sense that something is wrong with the EC. So let me remove this epoxy. That's some no one, I have to take my time. But I turn on the heat still, you know. Oh. It can't really melt the solder. So easy. Yeah. I look at things I never watch too much. Yeah, dog. Good thing I never watch it, dog. Alright, so I've moved the epoxy from around the chip here. So I'm going to So the reason why I don't check the clock is that it doesn't oscillate in the off condition. So in the S5 state, as the moment that you plug in the adapter, it will oscillate for about 50 milliseconds and then stops, and then re-oscillate when you press the switch. Alright, so I apply some heat there, so I'm going to see if I'm getting green lights. No green lights still. Still not getting a light. And as you can see, my fault is right here at this circuit here, because I'm not getting 3.4 volts on reflow. Reflow, yes. As you can see here, I'm getting 0.9 volts, and that is my problem. I should be getting 3.4 volts here, right? So let me see if even if I jump a wire and see if it works. So I'm gonna run a small jumper wire here and see what I get. Right, let's go. I'm going to run a small jumper wire here and see if I can force this 3.4 volts to the next side of the resistor, right? Could it be that the EC is pulling down the voltage on the next side of the resistor? Anybody? This is a fun repair, ain't it? Don't Paul?
Yeah.
I see green light. It works, you know. It actually turn on. And then by my plug out the power and plug it again. Gone. This can drive anybody crazy. You have to know what you're doing. Here on your watch it. That's possible. What is possible?
No, you ask if the EC are pull on
Of course the EC can pull on the voltage. Where's Heron? Is it Heron on the stream? Heron, are you watching? This is an urgent job, don't Paul? Can't do no work. Is that a producer? Is that a producer laptop? Some sound music in play?
Well, then, yeah, them produce.
It's urgent?
Well, you said Monday still.
Okay. Alright, so I have jumped a small wire here. And I'm going to see if I'm going to get the light.
Also, you send by the voltage on this.
Yeah, directly. So I'm going to jump the wire. Alright, let's see if we get any lights. And I still don't get any lights.
Oh, man. So weird.
So let's check if it's on. Let's check if we're getting on 0.9 volts still. And I'm getting 3.4 volts and it's not reading. So let me check the waveform if the EC is actually reading the contents of the charger. So I'm going to turn on the oscilloscope. Right, we should get a waveform here as well. So the EC to me seems like it's dead. So I'll have to replace the EC. I can't see. Hold on, let me just go under the microscope for a millisecond here. Yeah. Alright, so let me move the power. Alright, so I'm going to give power. As you can see, there's no reading. The EC is not reading. The EC is not reading. As you can see, I'm getting something there. Let's go again. No wave. See that? I'm not getting a waveform. Let me adjust my oscilloscope settings. I'm at 500 microseconds, right? 2 volts per division, and my trigger level is set to 925 millivolts. Everything is intact, and I'm still not getting any signal, so that means the EC is bad. Oops, microscope gone. Hey, minimize. All right, so again, see, we're not getting a wave there, nothing. So I'm going to replace the EC. Let me move this jumper wire here. See, the light on this is not bright enough, so it don't give me proper light for the camera. See? Yeah. If I use this, so I'm gonna get.
Go buy the next one.
I have to go buy a brighter.
No, like buy the next one. That's enough. Keep on.
That's my plan for two. Yeah, it makes sense though. Yeah. That's when I feel to do that. Yeah, we'll buy the next one. Alright, so I'm now removing this jumper wire here. So the EC is not working. I'm going to reflow it some more. Let me reflow the EC. 1, 2, 3 drops of solder there. And
reflow the first time.
no, let's remove the epoxy. No, this is the reflow now.
Should be.
Yeah. But that should not fix the problem. That normally, remember them put the epoxy on it so the chip can't lift.
Right.
So if it worked, the chip definitely bad. Alright, so I'm now reflowing the EC. Alright, there's a nudge. As you can see, the chip is now moving. Alright, so I can stop and make it cool. Alright, so that's the EC reflow. Hmm? Alright, it's now cool to a point. Let me add the power. Still not getting anything. Oh, let me turn it off. And still no lights. Still no lights. It's dead. Right, even if I try another DC jack. Still no lights. This is a brand new DC jack and still no lights there. So we replace the EC. I'm going to remove the EC. Let me see if I have one from a scrapboard rather. This is a A2737. 8737, yeah. A203787. Let me find one from a scrapboard. Oh, Paul, this one is a tough one.
Yeah, that was easy fix, man.
No, sir. Scrapboard. Donor board. Alright, Paul. This is the one that I run down in, Paul. This one is a A20.
Oh, it's a fix. Lock it up.
Nothing to I'm not going to my lunch today. Come on and rock me. I'll be waiting in the board, no buy, you know. Hold on, then I have a board, you know. No. No more than board there, you know. I have, but is a it's not I don't know. This one right? Power cycling. What are any of these boards? See? Some shots are going on this one. Only from a port. Only for the port I get problem. No man, on the camera.
Oh. No, let's focus on putting a care back on a warranty.
But me don't move it on. It always
Exactly.
use one way. I'm in a trouble. I just plug it in and left it. So one Paul. Yes.
One guy.
Buy them. So I buy board off of eBay now work, you know.
So what the fan too?
Yeah, no. Sometimes I get fan with them. I hope this EC is good. Alright, so I have a donor board here, and this is an EC. It seems that it was replaced already. Let me try it. This EC, I hope it works. So I'm going to remove this one, I'm going to prepare it, reball, and then solder. Which one? No? Fix not go fix it. Take accessories on that.
But English one chip.
You need a chip? Which chip?
Yeah. I'm doing a shitty job because
I mean take it off. I mean take it off.
Take it off.
The liquid damage. Alright.
What did I school there?
What you pay for it? $400? It's got 4 bits me pay for it. Buy it for my Christmas. Last year Christmas day I buy it for my Christmas.
Printer school?
Yeah. I'm gonna buy the BJ machine for my Christmas this year as well. The new BJ machine. So I have a next machine I'm gonna buy this Christmas. Yeah. Mm. I'm gonna go for the solder paste. Some shots are going as a brother. I can't deport my youth. Cause this is an angled. I must the wire. Go on. Pull the trigger. Yeah man, I wire. Go on. Pull the trigger. Alright, I'm gonna go for the paste. And you make them man 2-3.
2-3 then.
Worthless.
How much time?
You know. Can't win a match, brother. Alright, so here it is. Right. Alright, so we have a reball here. Alright, so I'm going to remove this one. Alright, so I'm going to solder the new chip, not the new chip, the replacement chip now that I took off the donor board, and see what I get. That one is messed up. I have to go again. I misaligned. Oh, first of all, let me check if the 3.3 volts is coming over after removing the EC. I didn't remember to check. Let me see if it's coming over. So I'm going to plug in the power.
No more nail I use.
Repeat that.
No more nail.
No more what?
No more nail.
I don't understand that, you know.
To get the magnet stable.
Alright, the match done. We lose.
Loose?
Yeah. We are still getting to 0.9 volts. And it's not 1 volt. So it's not the EC is the problem here. So I remove the EC and it's still not generating 3.4 volts here. It's here, but it's not coming over here. Paul, it's not working still.
Wow.
So I remove the EC and I'm still not getting 3.0 volts here. What a mess. Can anybody tell me what is this problem? Can anybody? What's causing this problem here? Can anybody tell me what's causing the problem here? I am still not getting the voltage coming over here. Right, so this is SMC BCOK chip here. Pin number 1 and 2. Pin number 1 and 2 here is 3.3 volts. It's coming from the charger IC. Pin number 4 is outputting to power this chip, 3.4 volts. That 3.4 volts is coming here, right? Pin number 5 is adapter sensing, which is working. Pin number 4, which is sys1 wire, right? So all the working conditions are there. So the EC is not at fault. The EC is still working. I'm going to remove this chip, U7000. I'm going to move it out of the way. I'm going to move it out of the way and see what I get. Because 3.4 volts is here, but it's not coming over here. It should come over, right? So that the EC can read the contents of the adapter, which is coming from here. Right, so this is okay. This is producing 3.4 volts to power this adapter sensing chip, but here is giving me a problem right here. All right, so I'm going to remove it. I am going to check again with another DC jack. Oh, we're getting 3.4, Paul.
Final.
So it is the port? The port is bad also? But I try a different port. The 3.4. Yeah, so why it never work? See that? I try a different port and the 3.4 volts come over. That weird. No man, I take off the EC. But I change the port. I try a different port and it still never work. Old port 0.9. So the old port I drop the voltage.
So the new one that you tried?
The new one work.
No, not the new one, like the one before.
That's the same one.
Oh.
All them new.
No, like the first one that came.
Only one we change, and you see there. So I'm getting 3.4 volts on both sides now of the resistor.
So you remove the wire right from?
Yeah, man, long time. The 3.4 volts is coming over on both sides. But I tried a different port. It wasn't coming over. So let me solder the EC. Alright, so I'm going to solder I'm going to put back the EC and see what happened.
You shop that in here, sir?
Down the road.
How far down the road?
On the next road?
What? On the next road?
Yeah, there's a shop. I go walk, but no, it's not really far, you know.
Huh?
Not really that far.
It's far, man.
Don't want me spec you, isn't it?
Where you walk to the yard?
Yeah, no, yeah. So I go walk, come down through the step then, so. And then go down. And then I turn. And then you go down and you see.
Sounds hard.
No far, man. They say raw Paul, I get something to eat. Oh boy. Children of God. Hammering. Hmm? No, no. No luck.
I'll try it.
All right, so let's see if what we get from this unit. and there's still no lights. I'm getting 3.4 volts now, and there's still no lights there on both sides of the resistor, and there's still no light coming out. Alright, so I'm going to replace this EC now. This is the original one I put there. So I'm going to use another one. The first one, the one that I was supposed to put there. Alright, so I'm going to try this one. And then I'll see what I get. Oh, you found it. Ah, I'm getting burned. Hold on. Find it, Paul. Yeah, exercise night, ain't it?
Oh, kasi naman yung ulit, Bern.
Yes, sir. Exercise.
Okay. Find out now.
No, I put on a different one. I put on the original one, but it didn't light. All right. Find Miss Peggy. Oh.
Sophia.
Where you go so far?
What do you mean far? I don't come on by you. Try to see.
You carry the lunch?
No?
You spell about that?
Sophia right so.
Cook food over here?
Yeah?
Cook food over here?
Yeah, she said she only for weekend.
Me never do that. Me never do that. Me never do that.
The person can go down the river.
What tell him? No, Friday. Alright, so I'm going to connect this supply now. And there's still no green light. Alright, I'm using the new port. I'm not sure this EC is good either. I took it from a board that it already took off. Still no lights, Paul. Still no lights. I'm gonna try and see if we can find one from a board. Alright, so reset is there. Yeah, reset is there. This is reset. We have supply. We have power there going to it. And the clock won't work unless we turn on the board. It tastes good? We never know how to cook food set over here. Interesting. You teach me something today. I'm my own community. Paul, go back. Are you lucky, sir?
No, because when I'm going, I say, what do you say? So you say, fine. But you cannot hear it out. And I say, maybe yes. I'm going to say, Sophia. I say,
No, I'm say Peggy. Say Miss Peggy.
So you know what? You don't bust me in, I'm not further.
I don't know what's the food sell over here, dog. Right, I'm getting 3.4 volts here, but I'm still not getting a light. No, this is getting interesting now. Let me check up here on the DC jack section. I don't think this EC is good either. Jehovah's Witness? You believe in them?
No. They don't believe in the Bible.
You don't believe in the Bible?
They don't believe in the one book. They write in one book.
3.3,
They push them book.
4.5, 19. Everything is there. 3 volts is here. Oh, it dropped to 1 volt now. So your port definitely have a kill the voltage. So your port a kill the voltage. Alright, so now I get another EC. See if we can find our next EC. I don't think this one might work. See there? 3.4 volts. Everything is there. Still no green light. Still no green light. No orange or green light. So much for that. How much for that food? Alright, so I'm going to stop the stream now. And I'm going to see if I can find another EC. But I've been streaming for a while. So I'm going to stop. Alright, so let me see if I can find an EC first. 2 hours and 40 minutes streaming, that's long. How much? Let me check. Just look on the time. How much? 3, what? Them determined. I have EC, but guess what now? This EC are gonna make the screen show small. This guy's not the right one, it's small. Small. 87. Come on, normally buy them here. For sell. Them are work, them not them have a fault, but this one say chimes, no internal or external. Yeah. Let me see if I find any more. This one. Ah! Find one. No display. Aha! Alright. Alright, I found the board. The exact board, but this one says no display. So suppose these are donor boards. I get them. I buy them as is. So you think I can fix this one instead?
Yeah, but what is RAM different?
I think it said no display. It's the same exact board.
Yeah, but what is RAM side different? Or just one side?
One side. No, this is different. This is different. You're one of our dedicated graphics card. So I can't. This one of our dedicated graphics card. You see the heat?
Yeah.
Yes, this up. But it's have the same PCH. It have the same brand RAM, Skynix, Hynix, and everything is the same. So I'm gonna. Only difference with this is just that it have a dedicated graphic card. This don't.
Okay.
So this is the A200138. This is a 20. Oh, this is a 2015, and this is a 2014. See the touchpad connection different. Touchpad connections are different. So this is a 2015. This is a 2014. Should work. Same family them, so I'm gonna try. So I'm gonna take off this EC. Alright, so let's try this EC. This one at least giving me power. So I'm going to remove this EC.
Yeah, test it first.
Test it, it turn on.
No, I'm gonna get green light.
Yeah, it turn on, yeah, see there? So you want me to test it, so I will just test it to see if it wants to see green light. Want to see green light? Alright, here is the green light. What? No green light, but the board on. Where's the green light? You're right. But the board turn on. So could it be that something is wrong with my power? The board is on, but I'm not getting a green light. But it turns on. How is that possible? Oh, it's a airport. It's a airport. Airport. Definitely not. Yeah.
Try that port.
So, I'm a new port there. Alright then now. We just have it. Where it gone? Oh. Airport have a problem, Paul. Does it turn on the board, you know? Look, see?
Green.
No. So what's going on? So am I think I get trouble then? Lend me that. Let me do one over that. See there, the board on, you know? The board, the laptop fully on. But me not getting a green light. The board is fully on. The phone a ring?
Yeah.
Well, I can enjoy the food, Paul, man. Like it tastes good. Like me need to give it a try. Put up rice and peas meat last night, so I'm gonna want rice and peas. I want to know if this thing I might feast I might think I mess with me, you know. No. Still no green light. But this is a new port. Still no green light. And the board on. The board on. No man, something going down here. This is
New original.
yeah, a brand new port this. And a different board. I know me can't see a light. So let me check the signal if it come now. 3.3 volts. So one side have 3.4, next side 3.4, but it does not, there's no green light. There is no green light. .4, next side 3.4, but still no green lights. That's weird. That weird, brother. I'm gonna try and export. That import a brand new, you know. I mean a brand new port, my buy. Oh, we get green light now. Hey, we get orange light. So all this time the board was not giving me. We get orange light on this port. Sure. So how my port bad though? I wonder if the board I do it. Well, how? How?
So put backward on first.
See there? It's a virgin board. See? Board fully on. So I fixed it. It was fixed long time. I never know. The board was fixed. So the board was repaired a long time and I didn't know. I tried another port. This port is, my new port is not giving me good coverage. Not working. Weird. And I tried another new one and I got orange lights. And it turns on. Weird. Can I change the chip? I changed the SMC. So the board was repaired a long time ago? Let me try again. I'll try. Green light. And orange light. And you get lights there, as you can see, there's lights. So So the board was repaired. The board was repaired, Paul. So let's check the waveform to see how the waveform is generated during the moment of plugging in the charger. And this only comes once. This signal only generates once. I repaired the laptop a long time ago and I didn't know. Due to yeah, the board repaired a long time. See there? See? Alright, I can't show you the DC power supply because it's let me see if I can lower the angle of this DC power supply so you can see the current and see that it's actually turning on. This is my second DC power supply. Alright, so I'm plugging in the charger now. Alright, Paul enjoying his lunch. There we go, we have green lights. As you can see, we have 1.6 ampere there, 1.7, so the board is repaired. 2 ampere, and it's perfectly working. So the port is bad, and the EC was bad. So this is the new EC I put on it. So let's see if we're getting display now, and everything boots up fine. Oh, the waveform. Alright, so let's take a look at the waveform. Alright, so let's go under the microscope for this waveform and see how it looks. I feel like I want to repair something else. Alright, so here we go. So this side here is where we're going to put our probe. This is the sys1 wire. Alright, take a look at the oscilloscope. As you can see, there's the wave. Very good. The waveform is there. Alright, let's do it one more time. There we go. So the EC is now reading the, as you can see, the EC is now reading the contents of the charger. Right, that is the waveform there, and that indicates that all is working. Let me drop the voltage to a little bit more. Alright, you can't go no lower. Alright, so give power again. There you go. So as you can see, the EC is reading the contents of the charger, and all is well. So that indicates that the system, the EC is perfectly working and it's reading the contents of the charger, and the battery will be charged as well. So I'm going to put this in the case and we're going to see if the battery is charging. I'm just going to do a rough assembly. I'm not going to put in the screws. This one? It's on my one, so this are yeah, printers. Alright, so the board was repaired a long time ago. I have a bad new port. Can't believe it. So this is bad. And my new port is also bad. I can't believe it. My new port is not giving me nothing out of it. Let me try it again. I can't believe this is a new port. But it works. But the light is just not glowing. And it doesn't even turn on the system. See? And it's not turning on. Oh, sorry, I didn't give power. As you can see, there's no lights and it's not turning on. Right, this port is not working. This port is not working. My new port is not working, and this is what causing me the headache, where I didn't realize that the laptop was fixed a long time ago. Oh boy. Alright, so I'm going to put this screw. Get me a screw, Paul. Let me get 2 screws so I can no. Put in the socket first. Paul, enjoy the lunch. Can't believe this. I can't believe that somebody, eh? I'd have to try that. Because I don't believe in them people. I don't believe in them, brother. Come and say all on it. I never see you go outside with no food. How much feed are there? You have screw? 1, 2 screw for the port. The DC jack. For the DC jack, yeah. Hmm? Mic? Yeah, man. Yeah, you hear it?
Yeah.
Clear as day? 5. 8 hours I get? Yeah, 8 hours battery. I did pan it though, pan the receiver. Hmm? Yes, sir. Park? Which part? We can't what?
You can't see the camera.
Oh, no, not right now. Yeah. I'm gonna set up a camera there, so yet.
Yo, wireless is cameras?
Wireless, yeah. With audio and everything.
So, what? Solar powered?
What? No, man. You have to send 12 volts to it differently. Them have charged, them come with adapters.
Okay.
So we just extend the wire them through Cat 5. We will send pour them through them there.
Okay.
Yeah, through the Ethernet. Paul fine cook food. I mean never know some cook food so all these years. You know like I'm gonna go down on the road there as a matter of fact?
Really?
No, I'm gonna go down there. Not a reason. I'm gonna go shop. Supermarket, my brother. Brazil. What is a clipper? Clipper Sylvia? What? Alright, so connect the keyboard. Trackpad. Speaker. Don't need to connect external the data board for the USB. I'll connect the display. Can't believe the board is fixed a long time to rot it, I never know. Sure. Something I see, man. Something I put me in a beer problem, you know. Can't see it. Can't see it, Paul. I can't see. Oh, it's a block me from morning.
Wow, I'm roasted. To do that when I grow.
Oh shit.
I guess. Working. You want the SSD?
Yeah.
No. Don't make one. Yeah, absolutely. Yeah, screwed up on it. Alright. Wow.
All right. All right, we have Apple logo. The Apple logo is big. Oops, I need some more screws. Some more screws.
Yeah,
Fan, and
fan.
More the next fan.
You want a big long ugly one?
Hold on, let me just. The battery drag out too much. Every time I see this, remember prismatic, you know. Every time I see the laptop and the battery connector, I remember prismatic. But then bridge out the battery them, wall of the wire them. And tell me say me mash up the screen. I say, oh, brother, you give me a dead laptop. Hold me if you mash up the screen and the laptop is dead. Eh? The laptop dead, you know? Man, give me laptop dead, you know? And then fix the board and the man say, mash up the screen. That makes sense for you, Paul?
Nah.
Yeah, give me a dead laptop. Very proof there.
Yeah, very proof that the screen was working.
Yeah, very proof there.
How did him know the screen? The laptop come to him there.
Yeah.
Oh, come to everything on.
Which computer that? Oh!
Fun, eat things sit up on it.
You have some. You never give me screw then.
No. You want fun?
Yeah, give me the next one. Yeah, for the graphics.
The 3 screw them
So I'll make sure I say. That's not right. Right. Hold on. Oh man. Alright.
The arcade station have a standby now.
Which one?
Turn the panel now.
The what?
You turn it upside down or whatever.
Oh, so one jumping on me now? One, a two, you give me a one.
I'll trade them the panel.
So why you never give me them in my hand? Hold on. No? Laptop screw that. Hold on there. I'll check my lap. Alright. Not no drop on the ground.
Look over some.
See the fun, the screw them, they not the fun. Oh, shit. Boom, going in so. Shoot. What's a tree?
Yeah.
Sure, that's it.
What's the time?
Two.
Say get I'll trade that now.
Hmm?
Say get I'll trade that now.
Unless one more drop. So one drop. Oops. You don't say they put the screw them in this. Anyway. Oh, one more screw for screw down that fan here. Alright, let me see the views. Six. I have 8 likes, lovely. Alright, so I'm going to take a look at the DC power supply here. You should get 3 ampere or 4 up to 4 ampere on this unit when the battery is charging. Let me fix this camera. Yeah, so we should get 4 ampere because the laptop was always working but the battery was just not charging, no lights. Alright, so I plug in the charger, I get 1.8. Alright, 2. Alright, 1.4. I'm not getting any lights. Lights is gone. The light is gone. Well, it's turning on the charger. No lights. You light it, did I while ago? No lights. 1.6. It has sensor charger, you know.
Right.
But the light. What if we mix them up? What if we mix them up, Paul? Can't we mix them up, you know? What if I mix them up? So our next new one, yeah? No, man. So we have charging LED, but it's not picking up the light. Let me see on this one. Yeah, look like we mixed them up. Sorry, I mixed it up, so I have to take it apart again. Luckily, I never put in all the screws. Alright, so I accidentally put the wrong DC jack in, but that's fine. Oh boy. One screw for the fan. Alright, that don't have to come out. Print over that. Yeah. Ratchet that the original one I put back in there now. And the bad one and the bad one I put back. And the bad one I put back in there to Ratchet. So I put the bad port back in the board that's supposed to be there. You trade way over there, so. Alright, see I'm peeling off the plastic. See, brand new. Alright, peel it off. That's a brand new port. Alright, so I'm going to assemble again. Because I was saying how it's not going up to 4 ampere. It's stuck at 1.2 and then stuck at 1.3, and that's regular current. It senses the current, but it's not reading. The EC cannot read the contents of the charger, the wattage, so it can charge the battery. So it will definitely stop charging the battery. Let me move this out of the way. Alright, so
Why man can't spend money on them job? Apply.
too dear. Mad, that's enough for them place, Rent them up here, Like me, where me know I build my building.
Yeah, but still.
Yeah. What time is it now? It's now 3:30. Time for me to go on the road in the next hour or so. About 5 I can leave. Oh, it's working. Chip out? Really? Chipmaster gone? But me on the internet, I hit me on stream too. Well, the LAN me I use on a Wi-Fi. I'm not really stream with Wi-Fi. I got drop frames. Therefore use a LAN, don't it? Yeah? I don't stream with Wi-Fi. Stream with LAN straight. Because I got drop frames. Okay. Yeah. But if you notice that's straight. Yeah, straight. LAN me I use, yeah. No, I'm not streaming Wi-Fi.
Laptop
See laptop here? Yeah, but this is for stream and recording.
So what is schema to the laptop?
No man, that too. We depend on that as well. So this we depend now,
Okay.
The thing I come from this.
On machine on. Yeah, job 259.
No? One year so? And the fan for that. And the maybe.
So what are some of the other back?
What are? Where?
Oh, the mic.
Is that the mic?
Oh, I'm not sure what.
Mm-hmm.
Streamline system.
I headphone jack there. Repeat that. I'm not find a more straight. I just thought we just say 3 but a 2 we find. Part and all the tricky part in a man, that part and
You realize when you talk in your background, you might not really pick me up.
Yeah. Which is good or bad?
No, it's good.
Alright, so I'm going to go again. So I'm going to connect the battery. Alright, so let's forget the screws for the fan. That's 1. That's 2. That's 3. Too short. Sure. Oh, find it. In a long time. Oh,
Find
sweeter. Yeah.
Find third one.
Yeah. Let's search for that, yeah, so. Yeah. Alright, so I'm going to connect the charger now. Right, so as it go, there we go, we have lights. So take a look at the DC power supply. We should get 3 ampere in fully charging state, up to 4 ampere. There we go. There we go, 3.4 ampere. 4 amp, so the battery is charging and you have display. So it should be 4 ampere at all times on these models when charging the battery while it's on. So if you're not getting if you're not getting up to 4 ampere, then there's something wrong. The battery is not charging. Alright, so we have display now. So I don't need to check any further because based on the current consumption, I know that the battery is charging. Right, so as you can see, it's now 3.8, right? And it's now in stable charging, as you can see. And that's a done job. So it's repaired. So the port was bad, my new port was bad, and the EC was bad, I believe. Yeah. So this is the EC. And this is the bad port. And also another bad port that I bought, not brand new, not working.
Tell them they want a refund.
Too late.
Past time.
Alright, so the battery is now charging. And turn it off. So I'll make a screw to finish it.
So you know the thumbs up and everything.
Not really, just fix, man. Alright, so
Thanks for watching, guys. Remember to like, subscribe, and share.
not really.
I'm selling things, bro.
It's Christmas time.
My dash of that pig and business, bro.
It's Christmas time.
It's not.
Alright, so next in my next repair, I'm going to do another MacBook. If you want to watch along, if you're bored, you can leave. Yeah, anybody is bored? Let me see how many people are viewing this thing. Anybody getting bored? I have 5 viewers. Anybody is bored?
You man.
3 hours in this stream. I have one more repair. Look at this.
No, just actually a school man speak about now.
Look at this one. This is another Apple. Think you can fix it? Think I can fix it? Alright, let's go. What is the time? It's now 4. Almost 4 o'clock here in Jamaica, I believe. It's 4. No, it's not 4. It's almost just 3:30. Let me set the... Uncle Sam. What? Get Lapson. What is that? IMX68. I don't understand that, Uncle Sam. Uncle Sam, I don't understand, Uncle Sam. What is that, Uncle Sam? Alright, so I have here a MacBook that they said that it's not turning on. It's an A. I don't know. There's a sticker here. I don't know what model it is. I think it's an A2141. I think. Touch bar. Yeah. Camera. What about my camera, Uncle Sam? Scope camera. The scope camera here. Oh, let me move this out the way that I can see. It's a 4K Ultra HD. Yeah. It's from RF. Oh God, I'm so tired. I'm going to repair this last laptop for the day. I hope the nuns are intact. If the nuns are intact, then I can't repair at the moment because the nuns are very expensive. The nuns are very expensive. Oh God. I'm sorry for enough of the man them, you know, when I do Apple, you know, Apple will take over this thing, you know. And, you know, so Apple manipulate the people, them. I tell them, say, yo, we are the better thing, you know, brother. Everybody have to take time going to Apple world, you know. Why? Apple. Real manipulative company, you know. Yeah, man, enough manipulate the world. So many people switch. I say, hey, I can give you a better computing service. Just get an Apple. And all your problems will be solved. No virus, no lags. Every security up to the maximum security. Alright guys, so I'm going to see if I can look at this computer system. It's not turning on. That was I got from the other tech. Right, and she told me that it's not turning on. Yeah, it's a female tech. It's a female tech. Oh, this is from this. I forgot to put them back in. I forgot to put them in it.
Yeah, always.
Hey, I never see it, I remember, you know. Does it work though? It stop liquid from going anything?
Yeah, man. Work, man. Very effective.
Hey, it work.
Very
So, I don't want to call or I'm calling?
I'm calm, brother.
I'm serious? I'm serious?
Yeah,
I'm stressed. Am I comfy?
Yeah.
So, I'm set till Monday.
Eh?
So, I'm set till Monday.
I don't know about the patient, brother.
Oh, shit. You go tell the man, see him so. What that? What that? No, this is a diagnostic tool we use to flash the RAM chip or so. So instead of soldering it off, you plug it out or so. So this is it's a SPI interface for access the chip here. Alright guys. I lost my USB. I lost USB there. I lost my meter USB. Let me check it. Oh, I know why. I lost it. Oh. It's not showing. Oh, there we go. So we have the USB back. My webcam here is now working. Alright, so I'm gonna see what's going on this computer. Right, so let's plug in the charger and see what we get on this one. Alright, so as you can see there, we have 5 volts and it's not boosting. Oh, it's boosting. As you can see, the current is, oh, I lost USB there as well. My USB is out of sync. All right, there we go. We have USB. Oh God. All right, there we go. We have USB on both sides now. Yes. All right, so let me try again. We have webcam on both. Okay. All right, so there we go. We have 5 volts and it's going all the way up to 19 volts. So it's boosting. And it's on. It's turning on. I'm getting 1 amp. So I'm not seeing anything on the screen, as you can see. It's now off. It's turning on back again. Hold on. Eh? No, that's one for the Type C one then. The Type C laptop is coming on. A printer, no. Alright, so as you can see, it's turning on and off repeatedly. And now it's off. It's not turning on. It turns on but no display, and then powers off. Do I have lights here? Oh, that's plugged out. Oh, I left something. Alright, so I'm going to take this apart. This is my last computer for the day, and I will conclude the stream. Oh, my microphone battery is dying. I wonder if I can charge it while using. I don't recommend it either. Yeah, I don't recommend it. Okay, so it's an A2141, guys. This is an A21. No, it's an A1990, sorry. It's an A1990. Alright, so let's check PP bus first. Not PP bus, the NAND supply. Let me remove the battery. Alright, so I'm removing the battery there. Alright, so let me check the NAND supply. This is an A1990 motherboard. This is a MacBook Pro A1990. Alright, so let's go. Today's Apple Day, you know. I get 324 and PP2 on 2.5 volts. 0.9 is okay. 1.8, that's also okay. Right, so all those power supplies are okay. Let me check RAM supply. RAM supply is good. Yeah, integrated. This is VCC. This is the RAM VDD supply. Sorry, for the graphics card. That's okay. I'm getting one. All right, this is for the VIDA memory. Sorry, and this is for the GPU main power supply. And this is the VCC SA. This is CPU core. That's okay. I get one. And this is VCC GT. This is the integrated graphics. And these are okay. Right? These are all okay. 3 volts and 5 volts. Right? 3 volt and 5 volt section is also okay, as you can see. Backlight section is also perfect. All right. we have a lot of screws to deal with here. Alright, let's see if we can remove them now, shall we? Ah. Never plan to. A 330 now? 339. That's down a boulevard this time I go and then go repair center, I believe. Oh, I forget the laptop for my boy there, Stuart. Samsung.
Stewie.
Stewie, we call him in high school. I would say st. Yeah. Stuart. Alright. Yeah, we're in the same class. From second form right up to fifth form. Being in the same class. We in the same class. You hear me tell you how I mean them in the same class?
Yeah, but no most meet and not friend.
Yeah, we're friends. We play basketball at the time for the school. All right. It's Christmas.
Look at this. These are stolen to celebrate what?
The birth.
No? Not that. Which was never done. Never done that. They are celebrating death. And man said, because often as you can. That is the communion.
Oh.
That's the only instruction in here. In relation to in life. In death. You never tell them going back. You never tell them celebrating death. Plus the Bible also tells us
Uncle Sam, 6 watching. Are we all working at the same time? I am. Okay. 6 people viewing the live stream. That's not bad. That's a very good thing. Listen up, Paul. Listen up.
yeah, now it also tells us you should not mourn somebody died.
Oh.
So many times.
Like him turn it off. So on, say I go down and shop it now. Oh, so the phone's live then. Good nah. No, sound man them when say me na music, you know, them that are them life right now. I'm stressed out. Like the one there with the woman with the screen. That not come through yet. That screen not come through yet.
Yeah, it's complete.
No man, the last one, the last one.
Last one. No, that's the mountain.
That one there the screen he tell it. What that? What the DC power supply? Yeah. Me it have to move.
No, I see. Now power keep on and go. 2.7.
Oh, that charge man. Just want to watch it. You see that charge, you know?
So low? Never say a 4 kilo.
Yeah, the 4.4, yeah, 4.3.
You're not going to.
That 3. Yeah man, it's a charge. It's a charge man.
So another.
Depends on how much charge in the battery. No, when the battery almost full, the current will go drop slowly, you know. When they're too full, man, that means that the battery there, like it half. Is that dead? Wanna watch it? To charge, man. Alright, so the board is out. What is? You give me so much. You give me so much. Calculate up, where I calculate up.
You not calculate correct?
I mean, I calculate correct?
Yeah, give me $1,000.
Oh.
Everything now.
Forgot to write the port of a $4,000 and the yeah, you're right. I remember saying I change the port. Yeah, correct as fat. Hold on, let me. I must have wait. Why so much money? Yeah, man, that charge still. Alright, so. Oh, this side of the board is very dirty. As you can see, we have a lot of dust here because of the vent intake, air intake. Where's the brush? Have it? Printer, a female, a printer one there. You see it?
Oh, no.
No, you will see it. Yeah. Yes, sir. Not sure not me. You have more UV light. Have more. I'm not sure none. Just work.
What's that field screwdriver?
Field screwdriver I use, yeah. Alright, so we have some more NANDs here. We have another power supply here. Enough man know that you know that, right? Enough man know that you know the current thing there, no? So if you have 4 when you get fast charge. You have a password?
No, I guess like this.
Oh, they're red, right? I did low. That much percentage you get now? They can in a show percentage. 6%. Alright, so this is another area here for the PP for the NAND. We have a short here, as you can see. We have a dead short here. This is why the machine was powering on and off, right? So I don't have to worry because I know that the TPS62180 is not dead. If the TPS62180 is dead, then it wouldn't boost, and we would have a short here on PP bus. So PP bus is giving me 190, 200, sorry. So I'm getting a good reading here on PP bus. So that indicates to me that the laptop, the TPS62180 is not broken. If the TPS62180 is broken, they would have a short here and the NANDs will be all burnt because the 12 volts will be going over to those NAND, and if 12 volts with that high current goes to the NAND chips, then it will fry the NANDs immediately and the laptop will be dead because the EFI, the UEFI is stored on one of the NANDs, right? The UEFI is stored on one of the NANDs, and that's where the NANDs will stay, right? So if the NANDs, if the NANDs is powered off, is that burnt, then you go and get a chime. So the chime is UEFI, right? So please bear that in mind. So if you don't get the chime, that means you have to check the working conditions of the NANDs. So let's go under the microscope. This is my last repair for the day. Let me see if I can fix this quickly. Shall we? Alright, so today is Apple repair day, as you can see, all Apple. So as you can see here, we have the NAND power supply. This is 2.5 volts, and this is the TPS62180 here, and I'm measuring here and I'm getting a short. As you can see, I'm getting a short reading here. right? So I hope this.
Burn.
This look burnt. Is this burnt? If this is burnt, then we are then the NAND on this side is dead.
Oh God.
This is burnt. So the NAND is dead. The NAND is dead. The NAND is fried. See there? We have a short there. We have a short here as well. So I know this NAND is dead. So it's a Toshiba brand or a Hynix brand. Let me see what brand is this. Yes, it's a Toshiba TSB 43228. This is a 128 gigabyte. TPS4 TBS 3228. This is a 128 gigabyte. And this is fried most likely. I'm going to remove the TPS 62180. And this is the nightmare chip that is always breaking and killing the MacBooks because of this TPS 62180. We still have a short, so that indicates that the NAND is dead. Let me clear here. We have some bumps here, so I won't go any further with this repair. Makes no sense. I will assemble the laptop tomorrow.
Remember to like, subscribe, and share.
Yes, like, subscribe, and share. Eh?
All subscribers.
About 9,200.
Road to 12K, guys. Road to 12K.
12,000. Alright, so check in again. And we still have a short, so that indicates that the NAND is dead. Still are getting a short reading. Oh boy. NAND them fry. Yeah, the NANDs are fried. On them fry, Paul. Alright. I have to change all of these NANDs. That's 1, 2, and over here. They're all fried. Let me take a look under the microscope here for this on this side for inspection. Okay. Alright, so this side is 2.50, so this side, so the NANDs on this side is quite fine. So I only need to replace, so this side is okay. This side is fine. So these NANDs are okay. So there's 4 of them. Right, so 2 on this side. So this is 512. So this is a 1 terabyte. This is a 1 terabyte board here because we have a 2 gigabyte of SRAM for the T2. Let me see if it's a 2 gigabyte SRAM. Yes, it's a 2 gigabytes, as you can see. APL 1027. Right, so this is a 2 gigabyte T2 SRAM chip here. So it can go up to 8 terabytes. So this MacBook can be upgraded up to 8 terabytes of SSD storage. So I have 2 here, 1 here, and 1 here. So this is added up to 1 terabyte. So I can only, oh, we have a lump here. Look, there's a burn in the chip here, as you can see. See that? So 20 volts, 12 volts hit this chip directly, as you can see. Here is you can see the burn here. As you can see, there's a burn there. Alright, so the TPS 62180 is a very poor design chip, which always kill these NANDs, as you can see here. See that? So the UEFI lost its house there. So the UEFI cannot function because the NANDs are not in operation. See that? There's a hole there. You see, Paul?
Yeah.
There's a bump there in that one. Let me see the next one. So most likely I have to replace both of them. This can be repaired because I only need to change two. This one is quite fine. This one is not bad. This one doesn't have any explosion, but you can see definitely this one is burnt. So what's the time? Do I have time? Let me see if I can remove it. So as you can see right there there's a swell. No, I'm just going to remove it to see the short is gone. I wouldn't repair it today, I'll repair it another time. Due to time. Yes, I'm just going to see if I can remove the let me see if I can get this metal off. 400 degrees. See if I can remove this metal. I thought that the TPS 62180 was safe and it was just a capacitor, but I'm not getting anything. This one is dead. So I'm trying to remove this metal shield here because it's gonna in my way. Huh? But it's in my way because I can't get to go under the chip when I'm lift. Yeah, so I want it out of my way so I can remove the chip from this angle. Alright, so it's now melting. I think I'm going to have to get my clamp to hold the board from moving. Alright, there we go. It's moving off, taking off. There we go. So the metal shield is removed. Now I'm going to just use my I'm not seeing the other one. So I'm going to slice away the glue here. Huh? The board, so I have to get my clamp holder. The board holder here will clamp it in place so it don't move. Alright, so here's the holder here. Alright, so I want to find my other, oh, here's it. This one is better, it's more firm. So I will now scrape remove the glue. So I'm going to take it from this side here, and I'm going to go on the.
I'm trying to
What?
I'm trying to
You have to buy them off. You have to take them off a board. You can't program them, you know. No, you have to take them off a scrap board. Scrap board? It is? About $25 to $30. Alright, so as you can see now I'm getting under the chip here, under the NAND. This part is very tricky because if you go too deep you can break the pads. And you can break important pads, and it's gonna be, you give yourself more work to run jumpers. There we go. So as you can see, it's now removed. So I can remove the board holder now. Alright, so I'm going to just add some, let me check the resistance again. My battery is going to die shortly, any moment. And we still have a short. So I will have to replace the other NAND. So I'm going to conclude the stream. So I still have a short, as you can see. The short is still there. So I have to change the other NAND chip. I won't do that today. Alright, so I'm going to stop. That was a long one. Alright, I'm going to stop streaming. Stop. Bye, Paul.